Good. So I think we could give it a start. So it's really nice to see that among all of the interesting talks on this last day of the PyCon, there's still many of you who are interested in also learn and get more about how to deal with them. Small language models and maybe apply in practice. So myself, I'm Linas Petkevičius, head of the AI Association in Lithuania, also the head of the Institute of Computer Science in the Vilnius University. And as an AI association, we very often try to organize various events. This, as a professional association, try to reach the goal that there is no such thing as too many talented AI people in Lithuania. So that means that when we organizing various events, and last year we had 20 in-person events all around Lithuania, mostly in Vilnius, but also in Kaunas, Klaipėda, Šiauliai, and other locations. So we very often organize not only like meetups or conferences, but also open for the public AI workshops. We try to do all of the events open for the public. But nevertheless, since we have many academic colleagues from various universities, that means that we also have a good touch with scientific community. So we, in many cases, organizing some additional events for the scientific community. And last few years, we have many scientific events. So for example, this year we'll have one of the most known probabilistic AI summer schools in Vilnius in Lithuania, as well as scientific conference on rules, reasoning, and many other top-notch applications in the field of the AI. Now, I think we could slightly shift to today's topic and what we want to give it a look. So how many of you already have the experience not only using, but maybe to have the adaptation experience on small or just typical large language models? So some of you, not all. So today we will try to look what is the main guidelines and main things to have the preparation, the minimal preparation for successful adaptation of your experimentation. So for that reason, we do have rather good help. So this Onslaught library, which is quite famous for this specific reason. It has over 60K in stars on the GitHub, and we will try to look through various preparations and collab illustrations today. And I will try to go through a few of the parts today. So we will start from generic reminder. So what we know about the LLMs and the small language models. So we will have the distinguish thing, and we will say that large language models, there's like any large language model, and the small, so it will be such language models which you could run and adapt on rather limited resources. Later, we will go through the steps on our data preparation and the formatting for our experimentation, and later we'll look how and what does it mean to do the adaptation or supervised fine-tuning. So I think we could have a clear vision that we using in some of the processes large language models. Of course, in many cases it could be rather overwhelming to use for simple tasks, but nevertheless, if we do have some capability for high resources, maybe that's sufficient for our case. So all the time when we're starting to say that and think about the large language models, everything starts from the data, and our data usually is either text, audio, or the images. And if we're dealing with the textual inputs all the time, the first step which happens is tokenization. So basically, all of the texts are clipped to the chunks, to small subwords, sometimes one letter, maybe sometimes it could be words. And all that process leads that each and specific model have its own unique word list. So that means when we taking some different model, whether it's a Gemma, whether it's some additional model like Grok or GPT or SS, so that means that the unique dictionary size is different. There's some specific tokens, like when the start and the end of the sentence appears in the text. But nevertheless, that means that when we're writing the input, after the first step to do the mapping on the dictionary, we passing the indexes of the dictionary. So what's happening in our given text? So all of the large language models in general doing the predictions that if we do have the textual information from the Wikipedia, scientific articles, and many other information which could be scraped or collected all around the world. So we have a lot of corpus data. So that means that we could tokenize everything, and later, based on our capabilities, so you probably have the case and the definition, the context window, which basically saying, so how many indexes we could use in our model. In this case, the context window would be 4, and we could start to prepare our prediction task. So basically from the word PyCon, we would predict is, from the con LT is predict best. And that means without any labeling, we could create our own data set with the inputs and the outputs, which later could be used for creating or adapting our model. So this is generic principle how the majority of the large language models are created in the first place. Now, this is good, but this is usually the stage 1. So when we having the pre-training stage, so it's just all of the texts prepared and just one by one tokens are predicted. This means that if you would ask some question, usually there's no such question in like Wikipedia. It might be unique information that we want to modify. So our large language model would not try to be flattering or nice. So that's why the second stage, which is instruction-based fine-tuning, is really crucial, and in the most cases sufficient. So that means that when we having that pre-trained model and we want to adapt for our specific task, so we need to have one additional step. So we need to create some additional material like Q&A texts. So we do know how flattering we want to our large language model to talk. So what kind of the information it should be focused, whether it's a math, whether it's a coding, whether it's documentation or some other applications. And that means that if you would create like typical 2 columns, we will see up in the moment about how easy it is. So that means from 2 columns, the question and the answer, we could prepare our data set for stage 2. So basically supervised fine-tuning task. Of course, if we really want to achieve the top-notch capabilities, reasoning capabilities and ability to solve specific hard tasks, usually there's a third additional stage, which includes the reasoning, which basically saying that, well, it's not sufficient to have the Q&A, 2 columns. We should also, in the answer, have additional tags for the thinking and step-by-step reasoning until the specific answer is outputted. But that's only for the top-notch final improvements. So when we looking at the small language models, we usually saying that we focusing on small models which could be run locally. Those usually do not have so much risks, like we could do not fear that data is leaving our data center and our device in some cases. We do not care about the token usage and too much prices based on what we could achieve. And these many frameworks like VLLM and others, but in today's workshop we will look at Ollama just from the simple purpose that it's quite easy to run and have the capability to play with it. Of course, it's two-sided sword. If we would take any large model, it would be really great, but it would require a lot of resources. If we would take really small model, it would run even on the smart device, but it probably would not be capable at a highest level. So there's always a choice for us what we want to select. But if we download some pre-trained models, so for example, one of the state-of-the-art a few days ago was released the Gemma 4. So that means that we could use only few lines of Python code. And if we serving the model, so that means that we could only import the Ollama and have the one line for the calling the model. So if we just slightly shift to the Colab notebook, and we could look that such model would allow to deal not only with the textual data, but also with the visual data. For example, if we set up with a few commands even in the Colab environment, so that would mean that within a few lines of the Python code, we could have the string output in our Python environment. As well, if you would add some additional one parameter to place as an argument the image, so that would allow for us to have the Q&A with the textual information as well. Now, so that means that it's quite easy to play around, and now we could start to focus. So how to not only use the models, but in some cases have the capabilities to adapt those models for our own tasks. So we will focus on the second stage, so supervised fine-tuning. So in this case, as mentioned, we would like to prepare some specific knowledge for our organizations, for our specific tasks that we're doing, and use that knowledge to adapt the large language model or small language model for knowing that information and be capable to run on that new additional data purely from the calling the large language model. So what we will need to do for that second stage is basically to prepare specific two columns, two specifically formatted columns, and one will be the input for the LLM. So basically what would be the typical input, like user would ask for some new question. And the second part would be the assistant part, or basically the output, what we expect the model to be output. So that means that different models like GPT, OS, IBM model or Gemma architecture have different types of the formatting. So that means that we from two columns, question and answer, need to have some specific formatting of our data. But it is quite an easy task. We could actually slightly look into that. So if we would take a few questions, like we have the additional material on, for example, our organization. So we have some possible questions which are not maybe in the public knowledge or not scraped and trained on the foundational models, and we're providing some specific answer about those kind of the questions. So that means that if we're placing that information to the template of the specific language model, so in this case the Java architecture, so after the formatting we're creating the textual one column which could be used for the fine-tuning experiments. So let's come back to the case. So as I mentioned, after the having two columns, we have the formatting to the final column, which will be used in our experiments. Now I could mention a few typical problems which appearing and also have the similar structure. So there's some specific adaptations like text to SQL. So for example, in your organization, persons very often want to query information from multiple databases from different tables, and all the times either writing the query or if we doing the integration wants to find the tables and later do the queries. So that means that we usually, even we have multiple database schemas, we could collect all possible combinations, table, column, and the row. So basically, if you have like even 10 different tables in few schemes, it would be hundreds of thousands of combinations. So you could really easily create the queries that if you have at least minimum description about so what is in the table, and there's some information about what it is in the columns or the rows. So that means that we could create the context that for this table and for this column and for this row, we could spit it out the select sentence, a SQL sentence from the model. So that means we could create the full data set of all possible cases and create as a data set for the training. Also, if we have some specific system outputs, so the majority of the large language models now have the capabilities to have systemic outputs. Systemic outputs saying that, well, I would like to have the JSON with a specific formatting, but in at least my experience, if you having the small models, usually they time to time fail to formatting in the right output. So that means, once again, if you have all of the documentation, all of the unit tests, so you could just create basically full combination of the data set with the illustrative example that, hey, this is my documentation, and if the user will ask some specific output, this is the output that we want to do. So nevertheless, this is totally different use cases, but the question, answer, the formatting in the general sense are the same. So let's look at the preparation and the training. So what is really good on the Onslaught library, that it provides and have the integration of a few additional really nice features. So the most beneficial feature is some specific training procedures. So usually, and for a long time, if you wanted to adopt any model, whether it's simple neural network, whether it's a large or small language model, so usually you needed to have rather large amount of the computational capacity in order to do that. With a few tricks which were quite old, but in the last few years developed quite fast in the industry. So it's low rank adaptation techniques and the quantized low rank adaptation techniques. Those were quite interesting mathematical methods which allowed to reduce the necessity of the computational power to adopt large language models. So that means that if we do have the formatted text, which contains the question and the answer from our database or knowledge information that we want to give for the model, so that means that now we could give it a try and run the adaptation. So this multiple ready-to-use Colab notebooks on the Onslaught, which only requires to change your data. Usually the example is providing the ready-to-use data for the illustrative examples, but if you just change the data for your own data set, that's it. All of the experimentation could be done in computation free from your resources environment. So in this case, the Colab environment. So if you just look, we just prepared and uploaded the data set. So basically we are interested only in the formatted column text, which contains the specific format. And that means that after just running the procedure, we only changed the data set loading. So in this case, now we loaded the Gemma free fine-tune CSV, and after running the procedure, we could see that within 5 minutes we could have the adapted model ready to use. Now, if we just come back to the experimentation, a few things which we should take into account. There's 3 parameters which are really important. So first one, of course, it is the low rank parameter R, which basically saying so how much of the computational power we want to spend. So the larger the parameter, so more resources will be necessary. So for example, if you select like 32, so instead of like 0.1% of the weights, you will adapt like 10% of the model. So that means the Colab is no longer an option. Of course, based on the amount of the data that you're providing for the fine-tuning the large language models, you might need to increase the number of episodes, and we'll usually just tracking the loss function. And finally, once again, this for the testing, I would recommend just set the temperature as low as possible, usually for the experimentation, to see whether the model is seeing the impact or not. So all of the large language models have the parameter temperature, which basically allowing to have from purely deterministic outputs to really creative ones. So it's just probabilistic sampling, and very often the temperature parameter is set like around 1 or 0.8, and that means that all the time that we giving the question, the model producing some new sample, new generated and imaginable output. If we're setting the parameter temperature to 0, basically, so that means that the model will produce most likely output from the maximal probabilities, and in most cases it could be basically deterministic. So in summary, I really encourage you to give it a try, and if you have any use case which allows for you just to create the Q&A 2 columns. So that means that you could create the formatted text format, which for different models requires like in different tokens to start the format for the assistant and output the answer that you want to know, and give it a try to do the fine-tuning. So it's really nice that, as I mentioned only a few days ago, we have the state-of-the-art Gemma 4 model. So that would basically mean that we need only a really small amount of adaptation. So I do hope so that you will have some effort and give it a try to not only use the large language models or small language models, but also give it a try to create and have your own domain-specific model as well. And I think we could move on to the Q&A because after 5 minutes, there are also like 5 different events happening. So we could have the Q&A now. Yes, maybe I was really quick. So there's GitHub repo with the slides and all of the tutorials as well. So the good property it is with those low rank techniques that 95% of the generic knowledge which knows about the coding and generic Q&A and multiple languages remains, but you just adding your specific organizational data to the model as well.
Mid-sized company, what other elements would you add when building system for the company?
Well, that's really a great question. And the main thing it is usually that when we having those small tasks, then it's quite easy. We selected the domain like Q&A or some specific task like text to SQL, and it's rather deterministic. We the more or less all of the questions in that domain. For the organization, usually there's multiple things from finance, from just support, from the supporting the documentation, the management wants to know everything. So it's slightly more tricky because now when we want to prepare the data, so it should have the twofold. So first, we need to cover all of the domains that we expect from the model. So usually the problem is that expectation is high and we do not have the data sets prepared, especially on the soft cases like communication on like generic things and between the departments and so on. And the second thing, once again, we getting what we asking for. So if we preparing the data for majority of the cases, we could expect that the model would work as expected, but as I mentioned, it's rather tricky as the organization is larger. So it's much more topics that we want to cover. And if we do not have the digital information of the organization ready, so it's a long way to have the successful implementation, of course. Great, so I will leave the slides and I'll just mention that at 12 we'll have the Q&A session here on the agentic models, risks, and the legal. So we will have the both experts from the legal and people who are using intensively agentic systems, and we will try to give it a try to look so what is not obvious in the field. So see you around in 30 minutes.